Hey Heinz, welcome back.
Thank you, Adam. Thanks for having me back. I'm very surprised. I think it's the third time, isn't it? Or the fourth time.
I think it's right. Yeah. We always were on point and we follow closely the agenda. So this time
Absolutely. Absolutely. Very, very much so.
organized. Exactly. And you said the last time you can speak the hardest language which Nelson Mandela was, or right? Was
No, I used to be able to talk a little bit in isiXhosa. But
okay.
that's a
How
long
how it
time
is
ago.
good morning in this language?
Good morning is molo. Well, that's just hello, molo. And you say usapila is how are you? Um, or you can say kunjani kuba. I used to be able to chat quite well, but it's a long time since I really spoke a lot. My wife was fluent in the language because she grew up in Transkei, which was one of the African homelands.
Okay.
And so she was fluent. It was really funny listening to her speaking to to people.
But you said the language produces funny noises, right? Isn't
Yeah,
this?
you've got the three different clicks. You've got the isiXhosa, which is on the side. You've got the ugqirha, which is on the top. Qirha. I'm not really good at these clicks, but at least I can do them somewhat. And then itrango, I think, is a spoon or something. I hope I'm not saying anything very rude. If
No,
I have
no.
any, if I have any Xhosa speakers, please correct me. They've actually are working on a isiXhosa lesson on Duolingo. They've got Zulu, but not Xhosa yet. So
Okay.
I do want to refresh myself. The funny thing was that my teacher in school was actually a white lady, and she wrote the textbook as well, which is really weird that they would have a white person writing a textbook for a language. It's like language which is not a white language. In
Yeah, this is it's
Africa.
called
So that's okay.
inclusivity, right? So even
Yeah,
yeah.
exactly. I never figured that out. But she was really, I mean, she was fluent, but it wasn't her mother tongue, right?
Okay.
But anyway, so I had a good teacher when I was young, but then I sort of lost touch with the language. It's a
So
great,
there are
lovely
no
language.
clicks in good mornings.
Yeah, I mean, it's as I said, it's when I grew up, it was sort of not done that whites would speak to blacks, and in South Africa you can say white and black because it's not a derogatory term
Okay.
to say that, but it wasn't done. People just didn't speak to each other. You just didn't. Like people would look at you funny if you spoke to somebody with different skin color.
If you would do, what would happen? They would answer on.
No. I mean, gee, I had a wonderful time. I would speak to anybody I could find. I would speak to, because I was
Okay.
learning the language. So whenever I was walking on the road, I'd stop people. We'd walk together and we'd talk. We'd have a chat.
Okay.
But I was one of the only. I mean, I was the only white kid walking around talking to talking to blacks. Got some
Okay.
funny looks, but I had a great time.
Now, what I
Uh,
actually ask in the good morning, in the good morning word in the language, are
yeah.
there no clicks?
No. I think it's too early.
Ah.
It's too exhausting. But
Now,
as far as I know, I mean, this might all be complete nonsense, but I heard that the the original language that didn't have clicks, like Zulu, for example, doesn't have clicks, but then the isiXhosa, they got more in contact with the San people, who were the original inhabitants of South Africa, and then I moved to Namibia and Botswana, and they have a lot of clicks. They've got far more clicks than
okay.
the South African Xhosas. And so, as far as I know, they sort of adopted that click into the language.
But actually, this is funny that there are actually no clicks in more languages, right? Because I mean, it's easy to produce a click, right? So I mean, there should be more clicks in other languages, right?
Well, try. Let's hear the three clicks. One on the top, and then one in the front, and one on the side. But then you have to combine that with the with
So
the
I
whole
was
word.
perfect already. I'm already
Oh, yeah,
like black
yeah.
African,
You
right?
can get a citizenship now. That's no problem at all. Just go
So
to
you, you could talk to me. I would could talk back, with my clicks, and There are lots of clicks on the Route 66, this will be. It's cool, actually. No, if you think about this, because, clicking would be as easy to produce, I would say. I mean, maybe it's easier than, the English "the" or something like for non-English speakers.
Yeah.
And
Or the German
there are
"ha."
no more languages with clicks inside, right? So
The
this
German
doesn't
"her," Heinz.
Heinz.
It's for Greeks. It's impossible. They can't say Heinz. They have to say Heinz.
But they could click. Everyone could click, right?
Yeah. No,
if you
it's surprising. I don't know if I agree with you, because I've when I was in school, most of the kids had problems with the clicks.
Yeah, I mean, not very particular clicks, but a general click could be actually, a good way to say I'm done or something like this, right? So just really, if you think about this, surprising that there are no more languages with clicks, just a few languages, and they feel somehow exotic.
Are you sure about that? Are there really just so few languages with clicks? I don't even know that. I'm not sure.
If you don't know it, it means it's already surprising, right? Because it should be more common then, right?
Yeah. I mean, there's. I don't know. I mean, to me, it's like the African languages are the ones with clicks, but there might be in the South.
Why there are no European languages with clicks, right? This would be interesting, for instance.
I don't think so.
Yeah, why not, right? Because
true.
If you think about this,
it is a sound.
Yeah, just a sound. So no European or English languages have clicks, which is interesting. Okay, we are completely following the agenda again. So we prepared half year, to talk about OpenJDK contribution, your contribution.
Oh, no, I wanted to talk about something else.
Oh, of course. But I prepared so well that I actually forgot what you contributed. Can you just remind me what was your contribution? Actually?
It was not very much. It was basically something which somebody else realized can be done better, and so they've changed it to be better.
Was it the empty stream, right?
It was parallel multiplication.
A parallel multiplication, exactly. Mm-hmm.
But I want to talk about something else because I've had this thought. I've written a course on virtual threads, and it's just a one-day course because really you don't need to know. You're not supposed to need to know too much to use them.
Okay. Right? So it's surprising that you can speak of one day about it, but.
No, one day it fills up the day. It definitely fills up the day because you do need to know a lot of things that can go wrong. Because when things go wrong, you need to be able to figure out what went wrong and how it went wrong. So it definitely is something which you need to be able to debug and so on. And also, you have the basics of virtual threading, which is fairly easy to understand. But then you have structured concurrency, which is also very easy to understand, but it has lots of sort of nuances and ways of coding which make it a lot nicer than before. But then you also have scoped values and a whole bunch of things that have changed. Plus the whole threading builders, you've got thread builders which have changed and so on. So there are a bunch of things to know. So one day for sure it fills up. There's no question about that. But of course that assumes you already know threads. Like you're very well versed with normal threading. Then it takes a day. So anyway, but what I wanted to say is there was there's one particular thing which I am going to try and explain via voice. I don't know if it's going to work, but we'll see. You've obviously heard of parallel streams, right? Have you ever used parallel streams?
Yes. You
have, okay. So here's a puzzle for you. And if you get it wrong, don't feel bad because almost everybody gets this one wrong. Okay, so I'm going to give you. We've got a serve with 8 cores. No hyperthreading, just 8 cores. Okay, so it's not a trick question. 8 cores. You've got a thread pool with 100 threads. All right. So there's the requests come in, and you've got a thread pool with 100 threads. Now, normally what you would do is you'd have a worker pool for the CPU intensive tasks, and your jobs, if you've got some computation will be given to this worker pool, will execute it, and normally the number of threads that will be active would be the same as the number of cores, or roughly the same as the number of cores. So you wouldn't have like 1,000 threads. You'd have just like 8 threads in this sort of worker CPU worker pool. All right, but now we don't. We've got just a pool of 100 threads. We're just waiting for incoming connections. All right, so the 100 connections come in at the same time, and each one of those does a parallel stream. All right, so now the question is, this is the puzzle, how many threads will be active working at the same time?
Okay. Now, to my apologies, I didn't work with parallel streams from, I think, before Corona started, because since Corona, so like 4 years maybe, I use lots of work in the clouds with serverless. And the idea, it works completely different, because on serverless, you have one process and doesn't make any on one CPU usually, so we don't use a lot of parallel streams. But what I remember is the following. So the parallel streams works with the fork join pool, right, internally. So we can configure this with from the command line with Parallelism, I think, right? So with the Parallelism, we can set the amount of threads. This is what I remember. Then what I also remember, I used a lot of this was parallel stream. No, this was confusion with completable future with the async where I can pass the pool. Okay, there's no pool. So it means we have one global pool with Parallelism 25 or with 100 or nothing. Nothing means 8 cores, right? 8 threads, nothing.
If you don't specify anything, it's going to be the number of cores or number of processes minus 1. So it'll be 7.
Very good, because I always thought it's +1, and the last time you told me I'm wrong, so I thought there is no plus. So now it's minus. So
minus
7.
It's always been minus 1. It's always been minus 1.
So we have one. Now the interesting part is this is what I don't know for sure, because it's how many instances of the pool are working.
Just one
instance is working. There's one fork join pool with 7 threads. Working parallel stream, we have 100 incoming incoming connections.
Correct.
So we only can have actually 7 threads
actively working. Okay. 107.
107.
Okay. Because the reason it's minus 1 is because the submitting thread, the thread that starts the parallel stream, also works.
Ah, okay.
He doesn't just sit around twiddling his thumbs.
Like Node.js, right? So like Node.js is like the maintaining thread or whatever, or not?
No, I haven't. Not with Node.js.
No, I mean the thread which is not specified, it does performed some works not to block the pull, right? So this is yeah, just like maintenance work, right? Like
so the thread that submitted the work is also doing the work, right?
Okay.
So this is why if you specify the common parallelism to 0, for example, if you specify it to 0, then you won't have any threads in the common pool, but you still will have 100 threads busy working at the same time.
That's cool. So now I understood you. What they're saying.
Okay.
It means I'm in the application server.
Yes.
And usually, I always worked in application server or Quarkus or something similar, right?
Sure.
So in the application server, we would have HTTP acceptor threads, and then we have something like, the work HTTP threads, like they are 30. So it means every of the threads, if it submits, to the pool, this thread already does the work. So there would be the 8 threads in the pool. So I would get then 37 threads, right? Because at most.
That's right, 37 threads working at the same time. Now, most people most people who've started using parallel threads have taken, it's not parallel threads, parallel streams, have taken them out again, because it's because of this. What happens is all of a sudden you have far more CPUs busy than you realized, than you expected. All right. Now, the reason why they do that is as a safety valve, because, for example, let's say you've got one particular workload that's taking a very long time. You still want the other workloads to make forward progress. All right. So this is the reason why they've got it. First of all, number of cores -1, number of processors -1, because the submitter is also going to help. It's also going to work. It's also going to be busy. But the result is that if in parallel you go and do parallel streams, you're going to have far more threads busy than you probably realized. Okay. So you understand what I'm saying?
Yeah. On that note, and one very interesting task force years ago, nothing to do with parallel streams, but somehow related, I guess. So there was a project, and the high tech wanted to be asynchronous everywhere, just for fun,
of course.
because back then everything was asynchronous, right? So so they put asynchronous on every class.
Okay.
And one asynchronous class called the other asynchronous class. So we have asynchronous, which calls asynchronous. And this was asynchronous annotation, which was executed by internal application server Glassfish pool back then, or Payara. And the pool was so the queue was bounded. So there was like incoming queue, and the threads were also bounded. And now, of course, in production, what happened then? After a while, all cluster nodes were shut down with zero activity, right? So it was not like they were busy, so just CPU utilization 0 and deadlock, so everything was shut down. And of course, what happened was, because one thread submitted a task, and this thread which submitted a task called another thread, which also submitted a task, but the queue was already full, so everything was stuck because it was impossible to resolve, right? So of course I just couldn't understand the problem first, and I remove all the asynchronous, and everything worked perfectly, and say, wow, there is really experienced consultant. 5 minutes work, everything is working, but I couldn't understand the code, just deleted it, right? So this was since then I'm a hero in the company. They ask me strange questions, so okay, the next time we do something, I will just delete it, right?
This is being recorded. You realize that?
Yeah, but we can remove it later, right? So no problem. I'm the host, I manipulate the stream constantly here. In another project problem, even more interesting, was WebLogic back then, and there were transactions. So there was they had also actually, you saw ever WebLogic console?
Yeah, a long time ago.
There was the old console was great, because at the what I recall is at the start screen you see actually the worker queues visually. So you saw actually what's going on.
Right.
And what happened is, after a while, the WebLogic became busy and busy and busy, and there was no load. Actually, there was more threads, more load, and then it shut down with out of memory error. And this was more interesting because what happened was the same problem, by the way. The queue was bounded, and there were transactions going on, and transaction to host, and then it was rollback, right? So a transaction could cause rollback, and the rollback was another process, which was backed. It was put again to the queue. But the queue is already full. So and then all the transactions try to be rolled back, and this caused like a cascade problem, and everything was shut down. And this is an interesting problem. And then back then, I can call it right now because WebLogic is no more operational, and and then we find the solution and we patch that, and by the way, the patch was also simple, just timeout, right? But then the project manager said, we an expensive WebLogic consultant will come and will verify our solution. And I remember, we were all tired, we couldn't sleep, and there was like no war room and everything, and in the morning, the guy arrives, and the first question is, have you thought of increasing, the heap in JVM? And we say, why, right? I mean, there's not a problem. So yeah, because the garbage collector will run less frequently, and then the and the project manager was quite technical. Said, you know what? Said to him, we will cancel the maintenance contract right now. This was the two stories with queues. I remember. Yeah, but it's somehow related, right? To prevent that,
Okay. So let me continue. So
and the last one,
okay,
also related. Right. Hopefully, I always wondered why, for instance, Glassfish, Payara, and OpenLiberty are fully operational if they are completely overloaded. So the application was completely down, so you couldn't do anything, but the admin console was fine. And the trick was, of course, there are two thread pools and connection pools, right? There was one small one for the admin, which was one thread running, was the maintenance thread, and the other was for the application, was also a great trick. So this was my war story so far.
So what you found there was a resource deadlock, and you can spot them in a thread dump, but not as easily as other types of deadlocks. So if you have a deadly embrace deadlock, those are really easy to spot. You basically make a thread dump, and at the bottom it says...
What is deadly embrace deadlock? What is it?
Deadly embrace is when you've got... normally it's a lock ordering deadlock. You've got two threads, and they are locking two locks in opposite orders. So it's A and B. The one locks A, then B. Other one first B, then A. So if, for example, if you're transferring from one bank to another, you want to lock both bank accounts for the transfer. But if at the same time you're transferring from bank account Germany to Austria, and at the same time from Austria to Germany, then you end up with this lock ordering deadlock, and you call it deadly embrace, and there's no way of breaking out of that. But for that, there's actually code inside the JDK and JVM to show you the deadlock. So you can do a thread dump, and at the bottom you see the deadlock. Okay. The thing is that if you have a resource deadlock, that it won't show it in the thread dump at the end, like as a summary to say this is your deadlock. You will see that there are threads waiting for things, like waiting on queues, waiting on semaphores, which are not making forward progress, not moving forward. So you could look for threads which are on the reentrant lock or on waiting on a blocking queue, for example, or on a semaphore. However, and here's where it gets to the topic of what I really want to talk about, is these things change a bit when we go to virtual threads. When you do a thread dump and you're using virtual threads, you only see the platform threads in your thread dump. You don't see the virtual threads in your thread dump. And there's a good reason for it. When you have platform threads, you might have a few hundred platform threads. But when you have virtual threads, you could have millions of virtual threads. So you don't want to first of all, stop the world whilst you're doing a thread dump with a million threads, and then you're like carrying on and on. I mean, each thread stack could be like 10 lines. You'd be like 10 million lines of dump just whilst you're doing a thread dump. So for virtual threads, you only see the platform threads when you're doing a thread dump. Normally. So you could see if one of the virtual threads has pinned your or is not or can't be swapped out from the platform thread. Then you will see that the platform thread is busy carrying a particular virtual thread.
One question about pinning. So
yes.
In one point of time, I think every virtual thread has to be pinned to a normal thread or to platform thread, right? For a short period of time for the execution, because the work which happens can be only done by the platform threads, right? Because the virtual threads are virtual threads. So I mean, you know what I mean?
Yes, exactly. No, the pinned is something different. They can be mounted. They're always
mounted. Okay, the term is mounted. Okay. Pinned is bad because means if you do I/O or whatever, then they are synchronized. They can be pinned. This is why you're rewriting the libraries, and mounted means for the work, right? Okay.
So if you synchronize and then you block the thread whilst you synchronize, then you get pinned. But what we're talking about is mounted and unmounted, right?
Okay.
So what I'm saying is if you make a thread dump and there's a thread which is mounted and can't be unmounted, or it's pinned, you'll see that in the thread dump. However, if you get a resource deadlock or a deadly embrace involving something like a reentrant lock, you don't see it at all inside the platform thread dump. So now what you need to do is to print all threads or dump all threads to file with J command, and then you've got like a million threads to look at to try and find your problem.
Big data.
It's gone from a small problem to a big problem to solve. If you get a resource deadlock, right? So what I want to now mention is we were talking about parallel streams in the context of if you've got a normal application server. Now, what's happening is there are two application servers which now offer the possibility of virtual threads. The one is Helidon version 4. It's going to be released in September, the version 4. And the other one is Jetty. Jetty also has the option of using virtual threads for your user threads.
And Quarkus is working on it.
Okay, I didn't know about that. So Quarkus as well. So the thing is with Jetty, the whole infrastructure is still using asynchronous networking, I/O, but you can run your user queries using virtual threads, which is really convenient. But the problem is you should never use a parallel stream from inside a virtual thread.
From inside of it. So virtual thread should not call parallel stream, because then the virtual thread becomes the submitter and one of the worker, right?
Exactly, you got it. 100%. Exactly right. And you've got a very limited number of carrier threads, and you don't want these carrier threads to be busy doing anything. So the workaround for that is...
Wait a second, the carrier threads. The virtual thread, why you know that it would be a carrier threads? It would be just a virtual thread, right? Or
okay, so the virtual thread, of course, is just virtual. It's not a real thread.
Yeah.
So when it executes it gets mounted onto a carrier thread.
Okay.
That's what we call that. So we've got the platform threads, they do the actual work, and your virtual thread gets mounted onto a carrier thread. It then executes until it finds the next checkpoint, and then it will go back to, it gets unmounted again, if it can, and then move on.
Okay.
So the problem is that if you have a bunch of threads which are doing, parallel streams, bunch of virtual threads, you'll block. First of all, you'll block up the carrier thread pool, so no other virtual threads can execute. Nothing can be unmounted from there. Nothing can execute. So that's the problem with this. So my recommendation, but it doesn't always work. My recommendation is that if you need to do a parallel stream, is to preface it with a call to basically forkjoinpool.getCommonPool.submit. So you're basically going to take your task, you're going to submit it to the common fork join pool as a task, and then get the job result from that. Because what then happens is that you are
This was the same trick. This was the same trick, by the way, for application servers to make parallel streams take the threads from the application server pool.
Yes, except now we're going in the opposite direction.
Yeah, exactly. But this was the same pattern. Exactly.
Yeah, we're going in the opposite direction. That we want to say we want to actually only use the threads from the common fork join pool. The problem where this doesn't work is when somebody has set up the common parallelism to be 0, which you can do. And one thing which is kind of nasty is that you can never really know whether or not you've got 0 threads inside the common fork join pool. I think we've spoken about this before. I'm not sure if we have.
About 0, no. I can remember this.
Your common fork join pool can have any number of threads in there. Can have 0, can have 1, 2, 1,000, whatever you want, right? And that is your desired parallelism of how many threads you want to have run at the same time. Now, if you're running, like you were speaking about serverless, if you want to run, with really small microservices, you don't want to have a lot of threads lying around. So what you could do is you could say, I'm going to make my common fork join pool equal 0.
It depends, right? Because what I do in serverless, actually, I use sometimes the fork join pool and I increase the parallelism. And the reason being is because I'm using for expensive I/O operations.
Okay.
So what I can do with it, so what I always did with parallel stream is actually only for that is, let's say in the stream, I have HTTP endpoints of microservices and I would call them in parallel. So then I have a parallel stream with a map, and the map will call, the service and return the value, and then I get back, and this was always the trick. And it gets even better in serverless, because even if you have just one core, you can still very easily, make everything parallel. This was the idea. Or reading, for instance. If I'm reading from S3 or from the database, so I can say, if I read, several things in parallel, I can say, go out, initiate everything, and then I can at least, save the latency.
But what you're confusing is concurrency and parallelism.
Yes.
Because you want to do it concurrently, not
Yes.
parallel.
Yes.
And what you're describing is really easy to do with structured concurrency. Like
Yeah, but I
super
don't have it
easy.
yet, right? So
Java
this is what I
21.
want. This is one that what I
Java
wanted
21 preview.
to tell you with the parallel stream is that I think for my cases, virtual threads is the way to go because it's exactly what I need, right?
Absolutely.
I don't need the parallel stream
structured
anymore.
Concurrency.
Yeah.
It's really, really good with that. You just basically make a structured task scope, I think it's called, shut down on failure, and you just fork a bunch of tasks and you say join, and once you're done, you're done. It's brilliant, really good.
But why now, without virtual threads, the parallel stream is still the simplest way to go for me, right?
Yeah, I'm going to say yes. It is the easiest way of doing it. Although I probably would not use the common fork draw and pull. I'd probably make another fork draw and pull for that. Not the common one, but what you've done will work. It will work. It's not really the way you're supposed to do it, but it will work. You see, the thing is, if you increase the common fork draw and pull size, it gets increased across the board. And for example, if you were to do a parallel sort, it would then spawn that many threads. Well, it would spawn. It would use as many threads as you've specified. Now you're running maybe on a single core machine, right?
Yeah.
But what's happening now is that you actually are instead of running on a single core machine, you're going to be running on you're going to make let's say if you made 100 threads, you're going to have 100 threads trying to use that CPU. Yeah. So lots of context switching, lots of contention for the...
Because what you said right now is, for me, it's fine because it's just I/O related, and but the problem is at the same time the parallel sort would be CPU bound, right? It was CPU operation.
Exactly, but that's what I'm saying.
This would be way slower than... Yeah, of course.
That's what I'm saying, is you're configuring the size of a particular resource incorrectly.
So this means if you have a large application and you don't know how many parallel streams are in there, it's a bad practice to increase the parallelism just to have concurrency. Yes, so it would be better, to create your own thread pool and use it.
Yes, you make another fork draw and pull of exactly the size you want, and then all you do is you do the parallel stream within that fork draw and pull.
In my case, it would be even easier, even better, because the problem is, you have to specify in serverless, the configuration to make it happen, and they have to see what is actually working. If you create your own pool, it will always work.
It will always work, exactly. And then you can configure it according to the network connections rather than any other just random number. You want control of that.
But I'm actually looking forward to virtual threads. But the last time you were very skeptical. Right, so you said
no, I was skeptical.
This was crap. I remember you said.
Okay. I was skeptical about part of the sale that they were part of their sales pitch. I didn't think was realistic.
Okay,
and their sales pitch was, now you can just write your own server in a simpler way. I don't want to write a server.
Yeah,
right. I want to use a server, and when I use a server, I want to make. I want my user request to be as simple as possible. Right, but I don't want to write my own server, and a lot of the sales pitch was, hey, if you want to write your own server, nobody wants to write their own server. Now, I believe that Jetty tried to use virtual threads for their infrastructure, and they basically undid that. But they do make it possible for us to run our user requests with virtual threads, and that makes a lot of sense. As long as the programmers realize that if you're going to do a parallel stream, preface it with a call to the common pull and fork, and submit it to that and join it afterwards. As long as you do that, you're okay. Then you can use parallel streams as much as you want, as long as they're done within with a common fork draw and pull. Now, what I wanted to say, getting back quickly to this the common pull, it can have a size 0. You can have no threads inside. But you can never find out if it has no threads inside.
But okay.
Well, I guess you could there could be a hack you could use to see whether it has no threads inside. But there's like no easy way to know if there are no threads inside. And the reason is that when I say get common pool size, it never returns 0. Even if there are no threads in there, it says the number 1.
Okay.
So it lies to us. It basically says, well, I know I've got no threads. I know that the size is 0, but I'm going to tell you 1 anyway. Okay?
Is it a bug or feature?
It's a feature. Right?
Okay.
And so, and the other thing is, if I've got a dual...
Why it is a feature? Because
I'll explain in a moment.
Okay.
Let's say I've got a single core machine. Okay. Now the formula is it's going to be the number of hardware threads minus 1, but it will have 1 thread in the common pool. So even if I've got a single core, it'll have 1 thread. If I've got dual core, it's going to say, well, I've got 2 threads minus 1, so it makes it 1 thread. Right. So basically, what I'm saying is that the answer from common fork to and pool get size is going to be, if you ask them for the size of how many threads you actually have in there, it's never going to say 0. It's going to say 1 or more, which means if you get the number 1, you either have 0 threads in there, or you've got 1 core, or you've got 2 cores. They all give the same answer.
Okay.
Right? And this makes it kind of difficult because, for example, if you do this trick of prefacing the parallel stream with a get the size, you can never find out whether you've got no threads. And if you've got no threads, the common pool, you'll never return. Right? So what you probably need to do there as well is to if we give back the value in 1, is to just do a normal parallel stream, and that's just not going to be very efficient. But at least you're not going to hang up the system completely.
Yes, because if you have 1 and there is actually 0, that will be as bad as before. The virtual threads will be used as the how to call it, submitter threads, right? But
exactly.
There is
exactly. So you'll jam up the virtual thread, but you're hoping at some point this expensive calculation will be done.
But that's different.
We'll finish.
Let's say we have 5, and I'm a little bit cautious what I'm doing. And the virtual threads, there will be 5 virtual threads then pinned to the parallel streams. So I get 5 plus 5, so I get 10 or 9. I get 9.
Not pinned. They'll be mounted.
They will be mounted.
Yeah.
But I mean, that's no problem. The problem is only if I'm not carry about that and I have unbounded. So I have no like a bulkhead. So I say all virtual threads go ahead and access the parallel stream. Then I have a problem. But if I would say just 5 or 10 or 20 and know what I'm doing, there's no problem at all, right?
Yeah, I mean it depends how many carrier threads you've got, right?
The question is why the virtual threads are accessing the parallel stream at all, right? Because if this is like a server and virtual thread,
I'll tell you why. Because because they say in the JEP they say don't use virtual threads for CPU intensive operations. Rather use parallel streams.
Oh,
right.
Okay.
I think they say that, or they say something like that.
If not, they will say this, right? In one point of time.
I think they do. I think they did. Or at least it's like
I won't cut it out just for the record, right? No.
I'm just want to quickly have a look because I want to see if they mention parallel streams. Yes, it says it is not a goal to offer new data parallelism construct in either the Java language or the Java libraries. The Stream API remains the preferred way to process large data sets in parallel. So this is sort of right from the beginning.
But still, just remember, we have now Helidon, NEMA, for instance. This is the virtual thread capable implementation. Let's say I would just have a JAX REST, so this is like the REST endpoint, which I do all the time, and this will allow me start 50 requests, and then every 50 requests will be a virtual threads behind the scenes, and the virtual threads will start parallel stream. And the problem is then all the advantage will disappear because the virtual thread becoming one point of time is mounted to a carrier thread, and the carrier thread is somehow a normal thread, right?
Yeah. Well, carrier threads is normal platform threads, nothing special.
So if I would have 50 normal threads, no problem. If I will 5, there's a bottleneck, right? So it would be.
If you had 50 normal threads, you'd be stressing the CPU.
Yeah.
But you'd still make forward progress.
Yeah.
It'd still make something would still happen. You'd still be able to make forward progress. But if you have 50 virtual threads trying to do this, you'll have only as many at the same time as you've got actual threads, actual carrier threads.
Mm-hmm. On that note, what's interesting in Quarkus, they have now reactive libraries, and the reactive libraries, I have to admit, I don't like them, right? So I wanted to say something else, but you have to use, how it's called, Uni, and there's no strange way to program things. I mean, the builder pattern is nice, but I don't like to learn reactive programming to program in Java. So this is a bit too lazy, right?
I understand.
So but this is many developers like to play with it, and I don't remember, there are lots of attempts. From Netflix there was a library, and there was I think Akka was also reactive. I almost forgot about that, and I always ignored this because even in large projects I never had to do this. So I never was in Google like infrastructure where you had to build a load balancer with millions of users. For me it was like enterprise apps, and I think several thousand transactions per second, maybe 10K was so this was the area, and it had without any magic, it just worked. Now, and what's interesting now, what I understood is what they will do is that if you use the reactive libraries behind the scenes, they will use Loom or virtual threads in Quarkus, which is interesting because I always ask the question, when I have to use reactive programming. And the answer was always for scalability. It's like, but
yes,
in my world, I understand it that every thread comes with overhead. I think 1 meg is a heap overhead, right? Something like this, or how much is it?
No. This is a fallacy.
Okay, so how much overhead and normal? Let's say we ignore all the virtual threads and all the reactive programming. We build a server. Every user gets a new thread. Done. No pooling, nothing. Right. So the question is, how bad is it? So I mean, we have one. Okay.
So the fallacy is that a lot of people think that our limit with platform threads is the stack size. Mm-hmm. But you can try this out. You can make a stack size of 1 gigabyte, for example, and then on your laptop you can make 10,000 threads. Mm-hmm. So you've got 10,000 threads times 1 gigabyte, 10 terabytes of memory, right?
Yeah.
On your laptop, no problem at all. This is just reserved memory. It's not actual physical RAM. Mm-hmm. So you don't have a limit. And not on a 64-bit machine. On a 32-bit machine, you do have a limit. On a 64-bit machine, there's no limit, effective limit, at least not at the moment, for how many threads we can make, physical threads. But the operating system does limit us. So the operating system will limit us from making more than a certain number of platform threads within a JVM. Mm-hmm. It's got nothing to do with the stack size.
But what we had already, out of memory errors because of too many threads.
Yeah, but that's artificial.
Maybe, but the problem
it is. It is artificial. It's artificial, and it's put there by the operating system.
Exactly. This was Windows, and I think around 400 to 600 threads were the problem out of memory, and we had to do. It
depends. It depends what you're running on. If you've got a 64-bit machine, and it depends on. So I've got like a bunch of different laptops. Mac. Every couple of years I have to buy another one because they keep on breaking, but they're still sort of working. So. And for example, on the current MacBook Pro I'm using, I can make 16,000 threads.
Okay.
On another one, I could only make 2,000 threads.
Another one was so Windows? Have you had any experience with Windows? Because back then I was pretty sure it was Windows 32 bits back then.
No, if it's 32-bit machine, then you're limited by memory.
Exactly. This was the problem.
But nobody uses 32-bit machines in 2023.
No, not now. This was like I think this was like.
But you're right. But that was a long time ago when we were children. They used to worry about these things.
Yeah, 10 years ago maybe. So maybe we were almost kids. Yeah. But And a 64-bit Windows machine, what is the limit, roughly?
I don't know. I'm not sure. I think it's going to be probably 10,000. Right?
Probably 10,000. So it means it doesn't really matter, right? So the limitation is going to be that it's not efficient.
No, well, it's the problem is that you there are several problems with making that many platform threads, right?
Yeah.
Because, for example, if you do a thread dump, and now you've got to scratch through 10,000 threads in the thread dump. Also, your context switching is going to go through the roof, so it's going to be less efficient. The thing is, if you've got 10,000,
have you tried that? It would be actually a cool experiment for you for a workshop, right? So I'm just writing the worst possible Java code, where for every request I'm creating a new thread, new platform thread.
Oh no, I've seen much worse than that. I've seen. You think that's the worst possible? No. I've seen it in a system which each time somebody connected, they constructed 5 native threads, five platform threads.
Okay.
And then after about 1,000 users, the system crashed, and they couldn't figure out why. So yeah.
How crash it? It just
out of memory error.
Okay.
The thing is, when you're running close on out of memory error on the threads, first of all, that number is dependent on where you're running it. So it's not safe to go above. I'm gonna say above like a few hundred. I wouldn't go above a few hundred threads.
No, exactly. This was always so. We had a few hundreds. We always had that problem.
Yeah.
But I would say a few hundred. This is still far more than we need in most of my applications.
Exactly.
Right. So we could actually write a dump Java code and it would work fine without any magic.
Exactly right. 100%. And I agree with that. It's most times. I mean, I'm using virtual threads on my Java specialist.eu web server. Right.
Yeah. Are you using or not using?
Of course. I mean, I need to own dog food, right?
Yeah, of course.
But I don't have to use the virtual threads because it's not like I'm getting 1 million visitors a second on my web server. I mean,
who knows? After the podcast, after you mentioned at the podcast, so no, this is like
now it's going to go to 1 million a second. But before your podcast, it wouldn't. Java specialists.eu. Don't go there. You're going to crash it.
Usually, I advise my guests not to mention the, because they get hacked. So everyone goes there, and the server just blows up, right? So I don't like to get a notice from Google or Amazon that I'm damaging the infrastructure.
Exactly.
But that is actually interesting. That not interesting, man. Good that you are saying this. But you mentioned out of memory error. What's also interesting, there is another error which comes shortly before the out-of-memory error. It is something to do the garbage collector cannot keep up. You remember the name? It's like the garbage collector is busy, and if you get this error, that is, the garbage collector cannot collect the garbage anymore. What is the name of the exception? You know what I mean? So if you know this is like replacement of out-of-memory error. So there is an out-of-memory, and there is another error which says, the garbage collector is just too busy to collect, your garbage, and then you get after this the maybe out of memory. So I saw this also a few times in my project. I forgot.
Well, you can see it in the GC logs, right? You'll see like.
No, you get an actual error. So
really?
you get an error, and this says like I forgot the name. I hope you know it right now.
I don't.
It means the garbage collector is working hard, but cannot collect the garbage anymore. This is the meaning of the error. But I forgot the exact. Really not. In my project, I was able to produce it a lot. Okay. And I always wonder why I don't get out of memory error. And then I look it up, and this is like the garbage collector is too busy to collect the errors. Mm-hmm.
Okay, interesting. I know that you can get. What can happen is that you're like on the verge of an out of memory error, but you're collecting just enough to not get out of memory error.
Exactly.
So you can get a situation where the system's 100% busy, only doing doing GC, but
then you get the exception. Then you will see.
I've not seen that. That exception.
I saw it already. So I have to look it up. But
is that recent or a while ago?
No, this is a while ago. Also 5 years ago or something like this.
Okay.
So,
so Java 6 or 5 or something like that.
No, Java 8 or 11, I think. Java 5 or 6 is too long ago. So,
I haven't seen that. And you don't remember which garbage collector that was, do you?
No, but it was the standard. I usually
G1
always
or
run, you know, always run the standard. So I don't.
Okay, so it would have been G1 then.
I guess so, yeah, because
I must look that up because I don't recall that. Interesting. Wonder how you would actually cause that. I mean, cause that like in a little app.
I think caused what was probably either hypersonic database or DerbyDB. I forgot one of these, or I think it was started on my server, so it was maybe even my blog. It run on Tomcat, and which JVM it is? Maybe Java 8, I think Java 8 for sure, and maybe Java 11 if I was able to upgrade that. But yeah. Yeah, I will look it up because I know as I see this, but I don't know, you know, the exact. But if you look it up, it's also clearly documented that that this can happen. And
Interesting.
yeah. So virtual threads. So you want to talk about that? So what interests me, are there any cases left, you know, for reactive programming? Because for me, reactive programming is about reactive use cases, and there can be some, you know. This is for me is like having a stream, you know, a stream like we have in Java, parallel stream. But if the stream is alive, so it means it gets, you know, new events, then it's for me reactive, right? So we have Kafka or JMS or whatever, and we get events from outside. So I'm reacting to the stream inline with map, filter, whatever, and this is for me reactive programming. But what I never understood is why they're using reactive programming for HTTP. Because HTTP was never reactive. You know, you call a request and you get responses as request-response. So I'm saying, okay, we could maybe misuse reactive programming to you know, to save the amount of threads or to minimize the amount of threads. But this is optimization, and what we do, we know we perform stress tests, and you know, the stress is higher than the numbers of employees in a company. You say, okay, then it's okay, then we go for it, right? So it's simple code always wins. So I'm really thinking about whether there are cases left for reactive programming.
I'm not sure. I've done one of the courses we run as a reactive programming course with Oleg Dokuka, who's written a book on reactive programming. He knows about 1 million use cases for and solutions to very, very complicated problems. And so I've actually I've hosted his course 3 times already in different parts of the world. And every time I listen to it, I walk away saying, "Oh my goodness, this stuff is really complicated. There's so many different use cases." So, in my very in my amateur opinion on this, I am still waiting to see a side-by-side comparison between the really hard reactive programming solutions versus what it would look like with virtual threads.
But in opposite to your attitude, I would say I'm not in my project. They don't have to be hyper optimized, right? So in my project,
sure. But some of the solutions are really complex because of the things that might go wrong.
Okay,
and I'm not sure how much that is being sort of thought through with virtual threads. To some extent, yes, but not everything.
Do you remember a pattern like Disruptor?
I remember the pattern, but I don't.
This was like a ring buffer with byte
array. Sure.
Yeah,
but that's for performance. That's
exactly.
Yeah.
But I remember the pattern. I could apply it, but I never had to, right? Because this is
exactly.
This is like exactly like reactive programming. I know how it works, and by the way, if you read the reactive manifesto and most of the implementations, they are somehow similar under the hood also to virtual threads, how they are working. So they are also like dispatching thread, you know, this is very similar to virtual thread. Right, for me, standard will always win, right? So I'm not interested to build in my own stuff. I'm really interested that the Oracle guys or whoever does it, right, the OpenJDK engineers provide a solution which is good enough and simple, and then we go for it, right? So this is what I really like.
Yes. All I'm saying is that there are some use cases which reactive programming solves, which I'm not sure will be that easy to do or possible to do with virtual threads.
This would be cool, an article or whatever, you know, that we say, or I have to invite, you know, your teacher or your how it's called.
Yeah, you should actually invite Oleg. Good idea, Oleg.
You know, and you just know, and then if the virtual threads are out, just know to see. And it would be also cool, you know, still cool, I would think the job for you just to create a simplest possible Java thread server. So very simple code, new thread start on every call, and see what it breaks and compare it to virtual thread, So and just post the code, say okay, this is 10,000 threads and this is the behavior and this is the throughut or whatever. Just returns hello.
No, that's a waste of time. I mean, I've got a virtual thread server that the very simple one that just echoes back and changes the case of the letters, and I take that up to 2 million threads, with virtual threads, and it's just happily chugs along.
Yeah, but 2 million threads. I'm not Facebook. I would say you will see the platform thread solution, and you will see it will increase whatever the resources until it breaks, and then we have the virtual thread, and it will probably linear. So okay, there is no changes, but you will see the code from the virtual thread and the simple code from Java, and now we are talking because we can say okay, you see. If you're building,
but the virtual thread and the platform thread look exactly the same.
Yeah, that's the problem.
The one that says
structure. You are right. There's actually even no difference, right? So maybe
exactly
the structured concurrency code, the task scope, if you have something to join, you can do it afterwards.
No, it's super simple. That's the thing. Is your
you're right. There's nothing to do.
Make your life really, really easy, and I really think that. Going forward, I mean, I don't care if the application server internally is using virtual threads or not, because who cares? I mean, if that's details. It doesn't matter. As I'm saying, this Nima's using it, which is part of Helidon, Project Helidon.
Yes. Mm-hmm.
So they're using it. They're using the virtual threads internally. But I don't care if they use Netty or virtual threads. I don't have a dog in the fight. I don't care. What I do want is I want to be able to run the user requests in virtual threads. That's important to me.
Yeah, but this is the whole deal, right? Because the user request is the transaction, or the request is what I'm interested in, right? This is what interests me in application servers. Because this is the entire deal is about the user. Because there's nothing else to do for the application servers. I mean, they have no...
Exactly. Application do what you want. But let the user threads, let me be able to run all my user requests in virtual threads.
Where I'm going with it is because in Quarkus, there's the classic libraries and the reactive. And as I already told you, I try to ignore the reactive stuff because If
you don't need it, don't worry about it.
Yeah, and the problem for me was that the normal Quarkus was always fast enough. And it was always my question, where is the limit? And I couldn't find any for me, for my cases. Okay, if there is no limit for me, for maybe, and then I had a chat that said, okay, if you're building load balancer or whatever, but I never build a load balancer. So I don't care. And this is also the question to you. Maybe, we have a simpler solution, just, there's a virtual thread, and then try, to misuse the virtual thread solution to use the platform threads behind the scenes without, the virtual thread. And just to see,
doesn't make sense. It actually doesn't make sense. It's because the ease of coding it's so easy coding it in virtual threads that you might as well just do that. And I don't see benefit.
You're right. It's a different solution.
I mean,
because there's
okay. So what you could do in structured programming, if you really wanted to, you could specify a thread factory that returns platform threads. So then you're running everything on platform threads, but I don't see the benefit of that.
But for students, I mean, there will be for students will be great because the platform you see off, you see that it breaks, and switch the virtual threads is the same solution, and it goes right. This will be a good.
No, it's not persuasive. It really isn't persuasive. It's
interesting to see this, but for me, if I'm with a fresh mind and I say you show me a virtual thread, I just say, see, this is the same code. There's one switch. Before is old Java, new Java. Old Java breaks, new Java runs. This would be a cool marketing.
I did write an experiment like that. I did for JT, for the JT server, where basically I would have a request coming in, and then I would communicate backwards and forwards with the client. And then I ran it without virtual threads, and I ran it with virtual threads, and with virtual threads it works. Without virtual threads, it breaks. So it's easy, very, very easy to make an experiment like that. The only problem is you've got to be careful where you run it, because if you run it on the Mac, the problem is that if you try and create sockets too quickly, you actually run out of sockets. So you're crashing because you're running out of sockets.
On Linux as well. Not too quickly, but you get, the file descriptor, right? Problem.
Yeah. So what I did is I've got a server running on Hetzner, and the only purpose of the service is to run experiments like this. And I've set it up so I can have millions of sockets open at the same time. And so I don't run into limits with that. But that's the thing, is like if you run it with platform threads or with virtual threads on the wrong machine, it's both going to fail. Because you run out of sockets before you run out of threads. But so this is why I don't think it would be instructive for the students to see it, because if you run to their machines, maybe it'll just break on the machines in both cases. And it's really something you want to be running on Linux, not on Mac or Windows.
There was really interesting discussion with you. I was completely unprepared, but I was forced to remember, the concurrency.
Still, you did really well, I must say. I didn't expect you, because I know you're on a completely different boat at the moment. I didn't think you do context switch so well. I'm very impressed. Really impressed.
You wanted to put me on the spot, but which is fun. I like it. I always challenge the entities of my workshops. Ask me whatever you like, and you did it. So this is it's just fun. I mean, this
absolutely.
I have to re-invite you back, of course, the next time to talk about something, right? So
we'll talk about something. Maybe we'll get to the topic we wanted to speak about last time, which you put into this time, which we didn't get to last time or this time.
Yeah, because virtual thread or what always interests me, the innovation in Java, what happens is lots of stuff is coming, and there's really interesting stuff, and I still think that the more I use Java, I would say I'm more and more impressed, right? So with everything, actually, you can write concise code, you can write highly scalable code. Everyone knows Java, so I would say if you would like to have more vacations, Java is the perfect programming language, because you don't have to constantly learn new stuff. You just write simple code and it mostly works, right?
Yeah, that's right. So on my server, actually, I was mentioning that I was using virtual threads on my server, and I'm using them for two things, right? The one thing I'm using them for is for timers, because I've got certain things. A few years ago, I upgraded to Java 11, or I think it was Java 11, and it actually broke something on my HTTP request client. It was actually before HTTP client. It was I was using something else, but it broke the redirects. Okay, and so I was doing a bunch of redirects, and it broke it so that I couldn't get any more inquiries on my web server. This is my bread and butter, right? I mean, I make my money from people sending me inquiries. Hey, would you like to come and do a course for me? And I broke it in July. I think it was July 2018, and it remained broken until April 2019.
There are lots of vacations then, right?
Yeah, and I said to my friend, business is really quiet at the moment. I'm not getting any inquiries. So then I eventually, somebody sent me an email saying, hey, I've been sending 3 inquiries. He didn't respond to them. I'm like, what the hell? I haven't had any inquiries for months. And then so I set up the service to once a day to fill in the inquiry forms, make sure they all work, right?
This reminds me.
Yeah.
About, but don't tell it anyone, right? Do you know the JAX conference in WJAX? You know, of course, right?
Yeah, JAX, of course, yes.
Yeah. They have other conferences like, Visual Basic and whatever, COBOL, whatever conferences, sure. Right? So, and I got lots of, marketing material from them.
Yeah.
And then what I did is, I created a spam filter, basically. And I say, whatever comes from this email, just, put it to trash, because sure. I will never talk at Visual Basic conference or COBOL today or whatever, right?
Of course.
And then it was before Corona, and then I wondered, so this year, and I say it's strange because 4 years and I never got any questions regarding conferences from the JAX or WJAX or whatever. It's this is did I said something wrong, or what's the problem, right? And
because you used to be like a feature on every single JAX conference. I wonder what happened to you. You just disappeared.
And then I had a client in Wiesbaden, and the JAX was, and I searched full text search in my mailbox for Wiesbaden and Frankfurt, And then I found, hundreds of emails from them. It's like, Adam, are you alive? What's wrong with you? No, and I said, oh man. So and then I remember the conferences. The next involvement will be at the WJAX in Munich. So everything resynced. I apologized, and this is what can happen, right? Even without virtual threads. Don't be too smart, with your filters. So
I was wondering what happened to you because you always were there and you just
I completely forgot the conference. I was so many. It's like something is missing. I was, and then this was the Jax. So I'm back in WJAX and then Jax, of course.
Oh right, okay.
Yeah. So this was my story, with inquiries of conferences.
So what I did was I set up a filter, not a filter, a timer, to once a day, send me an inquiry, right? And then once a week, I go through all my inquiry forms and I send inquiries to myself to make sure it works. Right?
Synthetic transaction, this is called.
Yeah, exactly. Just to make sure it works. So that if something goes wrong, I'll pick it up more quickly this time around. And the timer was a scheduled executor service, of course. But I'm running that on a virtual thread, which is nice because now I don't even have one platform thread for that. It's just a virtual thread. And then the other thing is, I did this a few years ago. I did this push-up challenge. We had to do 15,000 push-ups in 5 months.
A physical or virtual one?
That was actually a carrier thread one. It was a platform thread push-ups, not virtual push-ups.
Okay.
And so people could sign up for it, and if they got to bronze, silver, gold, they would get their name on my website. As having achieved that, but then the thing is, the CRM I'm using is quite slow, so it's I've got to send the request and I've got to get the names, and for each category I've got to send the request separately. So at 5 requests, and I wanted to speed it up because it's actually timing out in some of the things.
Okay.
So there also, what I did was I used completable futures. Which worked really, really well. Just completable future, and basically it would just then get the answer lazily in parallel. But I've moved those over to virtual threads as well. But I think I've kept it as completable future because it's a really nice model to work with.
The completable future, you can always pass the second. You can pass the thread pool, right? So you have a completely future.
Yeah, exactly. So you can pass into the virtual thread pool. The virtual. It's a new virtual thread per request execute or something like that.
Okay.
So I just passed in that, and it's also virtual threads now. So it's not using any platform threads.
So it means the listeners of the show can send you all inquiries at the same time, and you will process them correctly. And what also means between 2018 and 19, you have the longest vacations in your life, right?
Yeah, I kept surprisingly busy. I was like, I was just doing stuff. Wondering why nobody wants to engage my services.
This is for me was the same. I always wondered in May there was something in our conference, but there's maybe. And then I remember Jackson, the largest in Germany.
Because you always had the biggest room, you always had the biggest audience, and it's like Adam Bean's coming. It was like the big show. And I could never understand that. How you?
Well, now I'm back. This is just because of
Well, it's not like they're paying you to speak, so you didn't lose that much.
You pay a little, but it was not a big impact. It's not like I became homeless because of that, right? So thank you. I have to invite you back and just to talk about Java, right?
Yeah, we'll talk about Java one of these days.
Perfect.
All right.
Then see you then. Bye.
Thanks. Bye.